Hey class, it's Professor Nick Sensky at UNC Charlotte, and this is week 2 of the Rhino Python tutorials for the scripting class. And today's topics are conditionals and looping. So the first thing we want to talk about is the range command, and you might be familiar with range if you've done some work with Grasshopper. It's basically a command that takes a starting number and some ending number, and is going to return to you the range between those numbers. Actually, in order to do this, we need to go print range. So it starts counting at 1, and it's going to increment that 10 steps. So it doesn't actually get to 10, it gets to less than this number. So if you wanted to count from 1 to 10, you could say 1 comma 11. Okay, so it's kind of like traversing an index. By default, it counts by 1. If you want to change that, you can say, okay, I want to count from 1 to 11 by 2s, and that would get me that. Again, it's going to skip that last. It's going to skip that last number in the range, so it's going to get towards 11, but 1 less than that, which would be 9. So again, if you wanted to go to 11, you'd actually have to go to the next number. Okay. So it's a little tricky to get the hang of, but just remember that you basically want to add 1 to that last number. You can play with it different. So if I did 2 to 12 by 2s, so it's going to give me to 10. And again, this is just because of the way the indexes work on computers. The other way that you can use it that's really kind of handy is if you just put one number in, you get a range from 0 to that number. So again, this number minus 1 is 9. So it's great. It works with 3 arguments. You can do it with 1 argument, you just 10, or 1 to 10, or 1 to 10 with some kind of increment, right? So it's a pretty flexible piece. So that's range. Let's go ahead and just leave that. Actually, just leave that. The other thing I'll talk about are conditionals, and a conditional is basically a test. Okay. And these work basically by returning a value that's true or false. And you see when you type them into the Python editor, they turn blue because they're actually recognized as commands. Note that a capital T RUE is the command, is actually like the Boolean true, but a lowercase 1 is not. Same with false. Okay. So you basically run a test and say like, is the temperature less than 32 degrees? True or false, right? If it's true, then water will freeze. If not, it'll stay liquid. So you can run these kinds of tests. Let's actually take a look at these. So what does a test look like? You can do something like, let's say I equals 10. And just say like I greater than 5. And this will evaluate, this conditional here, and it'll return true or false. So I is greater than 5, yes. Is I greater than 15? False. Okay, pretty easy. Let's look at some other ones here. So you can say like, is I greater than or equal to 10? True, it's equal to 10. Okay, equal to or greater than. Equal to or less than, right? So that's another one. The other one you can do is equals equals, which means is I 10, and it is true. You can say like, is I 15? It is not. It is false. Okay. So those are basically. The other one that you can do is not equals. So you have a exclamation point equals 15. Is I not 15? True, it's not 15. Okay, so those are like really basic tests that you can do. So knowing those simple tests allows you to do more complex conditional statements. And the reason why these are important is because they can change the flow of your program. So a lot of times when we would run our programs, they would just execute each script in order. Basically, the flow is only one way. A conditional can actually change the flow. So you can say like, if the temperature is less than 32 degrees, turn on the water heater, right? If it's not, then don't do anything, right? Or if it's hot outside, I'll wear shorts, and if it's cold, I'll wear pants. So you can basically change the flow of things. Instead of having it just flow one way, you can have it branch off and make some decisions. So let's look at that. Let's look at the structure if. So you can say let's go back actually. Let's say I equals 42. And say if I greater than 20. So that's our conditional. Say if I is greater than 20. So if that evaluates to true, we will do whatever follows this colon. So now you got some punctuation. And you note that when I add a new line, you can see the indentation. That means I'm inside the if structure. So now the program, if this is true, will do whatever is inside the if structure. So I can say print greater than 20. Okay. And give that a run there. They'd say greater than 20. Okay. So what if we want to trigger something else? So basically that statement will only trigger if our thing is greater than 20. So if I did 19, nothing happens. Okay. So then we can do another clause where we can say else. And you note that the else goes under the if structure. So it's basically an alternate flow there. So greater than 20. Else, and see it creates a new line. Else, print less than 20. So actually, let's go back to 19 here. Less than 20. Okay, so you can see that structure works. Another thing that's useful to do is to say basically if it does not pass this test, I want to give it another test, and instead of doing consecutive kind of if statements, we can do else if. So basically, it's if it doesn't pass this, else, and then if it passed this test, then we're going to execute this statement. And the way we abbreviate else if is elif. So say if I is greater than 20. Okay, so if I is greater than 20, this thing triggers. Else if is not going to trigger. So let's say if I is less than 0. Okay, and then we're going to say print this is a negative number. Okay, and if in this particular set of tests here, so if I is greater than 20, it's going to say greater than 20. If I is less than 0, it's going to say it's a negative number. If both of the tests fail, we trigger the else, and it'll say less than 20. So let's say actually number is between 0 and 20. Okay. And let's go ahead and fire this off. So again, 21 greater than 20. Negative 5. This is a negative number. Alright, so let's see if we can make the else if go. This number is between 0 and 20. Okay? So again, we've changed the flow. It's actually got 3 different kinds of branches. So we can have our programs now make decisions. Okay? So that's a more complex flow control structure than we've used to. And you can take that structure and take the idea of range, and now we can begin to implement loops, which are some of the most powerful structures in programming. And one of the things that this does that's a little bit different than the way that Grasshopper works is, as you know, in Grasshopper, the flow, you can still have conditionals, but the flow still tends to be linear. With loops, you can have things repeat themselves in a very explicit way. In Grasshopper, the loops are kind of hidden. You can't really get at them. But to do true iteration is one of the real benefits of Python. So let's take a look at a loop. And the most common looping structure is called a for loop. And it looks like this. You can say for, and I a lot of times default and say I, or I in range, and we'll do a range. Let's go ahead and just say 10. Do that again. Again with the colon, new line is gonna put us inside the loop structure, and let's just say print if I run that, it's going to give me... What happens is that we set a variable I, and we're saying for each I inside range, and we know that range counts from 0 to 9, so it's got 10 things in it. It's going to say this is a loop. And basically what happens is that it runs through the loop the first time, and it prints this as a loop, and then it's going to go into this again. And basically it's like until this is satisfied, until we count through every object in this loop, it's not going to be done. When it is done, we're going to finish off our loop. We're going to end. It's always critical to have some kind of end condition inside a loop, or it'll run forever. You have what's called an infinite loop. Well, let's actually look at what's going on here. So let's just say this is number, and I'm going to say I in the loop. Oops. And so what I'm doing is we've got some text here, and then I'm going to get this variable I, which is actually going to count through the objects inside of the this like range list, and it's going to print some text, and then it's going to concatenate, which means it just adds that like data onto the list, and then it's going to add this other piece. Oh, and actually I should say to string. It's important. I need to convert this number to a string, which means convert to text. Okay. Let's take a look at this here. So this should print something good for us. It's actually wrong about that. It's not. It's toString in Python, and it's toString in Java. It's just string in Python. So str. Yeah, there you go. Oop, a little bit of spacing. Try that again. So you can see it just basically is going to iterate through those numbers there. Okay, so that's a really simple example of just basically counting through a list of numbers to see some text. Let's should note that another thing you can do is you can use the range, and you can actually increment it as you would before. So I can actually create different. So I can have it iterate. It's going to iterate through, but with an increment of 10. So it actually is really a nice compact structure for creating loops compared to the way you create loops in other languages. Another kind of looping structure is while. It's basically like as long as this statement is true, so like I greater than 10. You actually have to define it outside the loop. It's a little bit different than the way for works, but let's just do I equals. Let's just do I less than 10, and then we'll say I equals 0. So it starts off with 0, it's less than 10. We're going to go ahead and say print I, and then we'll say I equals I plus 1. And that's just going to basically keep adding 1 as we go through here, printing, and then it's going to stop when I is greater than 10. So there you go. So it's just a while is a different kind of structure. Than for. You can see that it evaluates the test a bit differently. Basically, the difference between them is that if you have a list of things that you want to iterate through, you can say like for I in my list. Then you can go ahead and use a for like a for structure. But just say something like this. But if you don't have things and you want to do kind of like a functional programming thing, kind of like you basically want to keep trying something until it satisfies a test, you might want to implement a like while loop. Okay, and that's basically like the difference between the two. A lot of the times we'll still be using this for loop structure, but I wanted to introduce the idea of the while loop as well. So those are both different kinds of common looping structures. We'll use those a lot. Okay, so let's actually try to make something with these now in our Rhino. We've done a lot of conceptual stuff. Let's get down to making stuff. First thing I want to do, we're going to be using Rhino. Rhino is import the Rhino script syntax library as RS, and we can just say something like simple for I in range. Let's just say 0, 1. 100. Yeah, let's do this. We're going to make some points. So we're going to say rs add point. And here you want to basically use I in order to be sort of like your incrementer. So that I is going to change. The value is going to go 0, 10, 20. So let's make that the x value in this list. And if we run that, yeah, I'm just going to make a list of points there. So that's pretty nice. So a lot of times we end up having to like delete these objects every time I want to run a script, and that doesn't really, it's not very helpful for learning and like debugging. So let's go ahead and implement just a real quick kind of reset here. So we're going to we want to select objects by type. And this is really handy. This basically gets us the like IDs of all of the objects of a certain type. There's different kinds of values here. What we want to do is actually select, in this case, you can say like all objects. Okay, so you can see the geometry type is the first argument, and then the second is the state of the objects. We don't need to worry about that. So we're going to get that as select objects by type 0. And let's actually put that into a list. So objects equals all the objects. And then we'll simply do rs delete objects. And which objects do we want to delete? We want to delete obs. Okay. And that way, every time we run this, we can change something. And that's going to like redo it. So that's kind of nice for us. See that? Okay. So just put that, reset. I don't know. And if you don't want that, working, you can go ahead and comment those lines out. Then it won't delete that. It's not something you need in every kind of code that you do, but I find it pretty handy for learning. Okay, so we've got this, structure for adding points. So that's pretty simple. Let's make it a little bit more complicated here. Let's go ahead and take like a circle or something. I'm just gonna make it at 0, 0, and we'll make it a radius of 1. So let's just look at how we might sort of implement sort of like an array command with this. So we can say my circle equals rs object, and the prompt is going to be select object, and that's it. So that get object is going to allow us to, when we click, it's going to give us that circle stored in memory as my circle. Okay, and then we can say for I in range. And we know what the radius of it is. We're just going to kind of cheat here. Let's actually implement something, spacing. We'll call it spacing institute. And so we'll say, actually let's do it this way. Start and spacing. This will make it really explicit how this works. So start will be 0, and will be 10. Spacing is a 2. And so we'll do start and spacing. There, now we got a nice little parametric structure here. Called this base object. Okay, start and spacing. And we'll say rs. Let's see here. We're going to want to copy this object. So we'll say rs copy object. What's the object that we want to copy? We want to copy my circle. And we want the translation vector. In this case, the translation vector is going to be, remember it's a list of coordinates. We're going to say that's actually going to be I, because basically this is just the x here. The x is going to count by 2's from 0 to 10. Copy object I. 0, 0, which should be pretty simple. Alright, let's run that, see if that works. Oh, you know what though? We got to get rid of this because that is going to delete our circle. Okay. you need to select object. And there you go. So we could do, that's kind of tight, so we can increase the spacing here. Let's go ahead and erase these. Okay, good. It actually ends up keeping it here. So anyway, that variable changing is gonna produce that. It's gonna produce the range here. So let's so you can make lots of circles. Okay. The other thing you can do is have what's called a nested loop, and what that is that that's basically a loop that runs inside of a loop, and that loop will run until it finishes, and then it'll increment the like parent loop. So let's try that. The way that we're going to do this, a real simple idea. This gave us kind of a linear list, like a linear loop. To do a nested loop, we can do a basically like a grid. Okay, and so we got the start and end. Let's go ahead and call this. Let's do H spacing and V spacing. So horizontal and vertical spacing. Okay, gotta make sure to change this here. H spacing. And we're going to keep the same start and end. We're going to make this a square grid. That's fine. So we have the loop, and we're going to actually do another loop. And let's actually call this X now, because this is actually going to be let's call this Y, and this will be the vertical spacing. So the X loop will actually run first. So this is X from start to end, horizontal spacing, and then when this one finishes, it'll increment the next one. And that'll change the Y coordinate, and then we'll run through the X loop again, and that should work. We gotta make sure that we get our indentation right. So this loop is nested inside of this. This statement is actually inside of this loop, and we're going to do X and Y. Those are our X and Y coordinates. Okay, so horizontal spacing 3, vertical spacing 3. Looks all right. Let's go ahead and try running that. So that kind of quickly shoots that out. Let's run that again, so you can see what happens with the drawing, because I think it's kind of interesting. So it's going to draw row by row, and it's interesting that Python, like, I think, gets to a certain point and it doesn't draw it kind of knows that it's going to be repeating this, and then it just eventually kind of finishes it in the buffer. So it's kind of interesting. Like it's like it doesn't, if it draws a lot of things, eventually it gets to a point where it just kind of draws them all at the same time, as opposed to actually showing you that thing drawing. Later on we'll look at ways to control that, but for now that's just kind of an interesting thing. Note that this is basically like the array command. I mean, this is kind of how the array command works, but you have a lot of parametric like control over it. The other thing that you can do besides just kind of copying object is you can also transform objects as you go, and this means that basically I could apply like a scale transformation, or I could rotate it or something like that. So let's do that. So the first, originally we just kind of moved it, and we did like a copy operation, but to make things a little bit more interesting, we could do something like changing the scale of the object. In order to do that, though, we need to be able to actually talk to that object. So let's just call this, current circle. And then within the loop, we're going to say rs scale object. And the scale is the current circle. And we need to get the origin of it, so let's just say rs. Let's see, area centroid. Yeah, centroid. Let's find that. Curve area centroid. Let's do that. Which is, yes, current circle. since we're using curves, we can safely use that curve area centroid. It's always good to know, if you don't know what command you're looking for, just go ahead and look it up in the help. Or if you don't know the syntax for the command, they do it all the time. Especially if you're familiar with Grasshopper, it's a really easy way just to apply that knowledge to scripting in Python. Okay, so we do that, and then under scaling, scale object. I lost my syntax there, so let's take a look at it. We want to look for the scale, and the scale is a list of 3 numbers that are in the x, y, and z axis for scale factors. Fine. So we'll do, I'm going to scale in all 3. And let's just call this I divided by 10, just to see. So we're going to scale uniformly in all directions. Alright, let's go ahead and run that. Oh, I think I got a bug in this. Yeah, curve area centroid actually doesn't just return the centroid, I think. It returns... Oh, it's actually... Yeah, so it returns a list, and the first element in the list is the centroid. The second element is the absolute error. So we have to do a little... Take this apart a little bit here. So let's just get... we'll just call this current circle center, and equals curve area centroid current circle. Yeah, and then we'll say, now remember this is a list here, current circle center. So what we're going to do is we're going to get element 0 in that list, and this is just basically an array, and so the first element in the array we can access by adding a bracket and saying 0. We'll talk more about lists a little bit later, but that's how you access that. Okay, so we have the circle, gets copied, we get the centroid of it as a list, we have the scale of it, so you want to scale that, add its centroid by a certain amount. Basically, this is going to be a very small, it's going to make a bunch of small circles that then get larger, assuming it works. There you go. Okay, and it's just as simple. So we can do transforms. Like I said, we can like rotate things. We can scale them. We can kind of jitter them a little bit in their move. But just as a way of thinking about this. So let's try to implement something a little bit more interesting. We can use a sine function, the mathematical sine function, to introduce sort of like an up and down kind of like gradient. So it sort of goes like you can see the sine wave. We can use that to modulate the scale transformation and just make it a bit more interesting. In order to use the sine function, though, we actually have to import the math library. So I did by default. We're going to implement the transform as a separate variable for now. It just makes it easier to work with in the structure. So we're going to say trans equals math.sin. And sine is in radians, and we typically think in terms of, sort of like from 0 to 360 degrees, that sort of thing. We don't think in terms of radians, in terms of pi. So I'd like to convert from sort of like degrees to radians, and to do that I use the radians command as well. So I'm going to do 360 is a full like revolution. It's going to go fully up and fully down in terms of like sine. So we're going to do 360 times, and basically I divided by whatever this total distance is up here. So this is going to increment in tens from 0 to about 100. And so basically, as this approaches 100, it's going to approach 360. So it's going to count from like 0 to 360. Oh, and then actually it reminds me, we really can't start counting at 0 because that'll actually make us divide by 0. So let's actually start counting at 1. The other thing you could do is just say I plus 1 here. But you just never want to divide by 0. Computers can't do that. They don't like to do that. It'll cause it to crash. So try to avoid that. We'll talk about that more later when it comes up. But yeah, so let's see. I divide by 100. Okay, now I've got my trans variable. I'm actually going to take this and do trans times 10 and copy that 3 times. And that's going to be my scale. Alright, let's see if this works here. Yeah, so you can see that. And actually, if we make this a little bit bigger, you get a better sense of that sine wave. Just change these numbers. Now that should be parametric. Like those two numbers should be related to each other by some variable. But we'll skip that for now. Yeah, and you can actually see that side. So 2 cycles is 360 degrees. If you wanted more, you just multiply 360 by, some number. You could say 5 cycles. And that also can be parametric. So that does 10, basically. Since it repeats, I guess you could do 180, and that actually gets you what you're looking for. So it's actually 5 cycles. So, one thing you could try would be implement this as a nested loop. So we did this in the x-axis, but can you do it in the x and the y with the sine? That would create an interesting pattern. Maybe just keep kind of adding like numbers to this. Remember that it's just going to repeat. So it might actually be just something. It might just be I divided by some number times. Actually, it could just be I times some number, since we're in degrees. So whatever you want each one of these increments to be, called 15 or something. Depends on the number of objects you have, right? But let's give that a shot, actually. Yeah. So right now it's just spread out over a long increment. But basically, if you adjusted this number as the number of degrees increases, you could get more complex patterns in your nested loop. So that's something that you could experiment with.